when we look at the median is now 5, and it had been at 5.5. It didn't go down by very much because the middle number really cares about what's happening in the middle here. It only takes into account the middle right here versus the extremes. This really low and this really high wait time didn't really, it didn't really bother it much because it was all about what's in the middle here. And there's a lot of 5s and 6s and 4s, and that's what it's focusing on. So the median didn't go down by much, as opposed to this mean that went down by almost 2 minutes, because it's inclusive and it includes the extremes. So whether that extreme was a 20, which is extreme, or here where the extremely high wait time was 8 minutes, and so here the extremely high wait time was 8 minutes, and so this went way down when that 20 got removed and replaced by a 2. So let's talk about that. The difference it makes when there's an extreme value in there. And when it doesn't change very much, that's called resistance. Resistance to extremes, basically. So a resistance statistic is if extreme values do not change the value of the statistic or the summary statistic. So is when extreme values do not change statistic. Okay, good. When extreme values do not change the summary statistic, so the median was changed, but not by much. So it was more resistant than the mean, which went down by 2 minutes as opposed to half a minute. So we would say that the median is much more resistant to extremes than the mean, because the mean dropped by 2 whole minutes as opposed to a half a minute. Now there's another kind of average that we're going to talk about, and that's the mode. And the mode is the data value that occurs most often. So some of you have experienced the mode already. If you get a bunch of 3s, then you get a 3 on your report card. If you get a bunch of 4s, then you get a 4. If you get a bunch of 2s, you get a 2, or whatever. But this is used sometimes, like when I think about a car salesman, I'm like, oh, they don't really compute very much. Or sometimes people hand them computations, but usually they're looking around the lot and they're like, you know what? On average, they're about 32 grand. And you're like, how did you compute that? And the reality is they are not listing them and finding the middle value or adding them all up and dividing by how many cars are on the lot. They are just looking around and they're like, that's what happens most of the time. So this mode average is used, even though we, in the sciences, it's not very rigorous. However, it must be talked about because it's used. So if I have a few remarks about all of these things. So if a data set has a skewed shape, which means it leans more to one side than the other, then we immediately use resistance statistics. We prefer not being pulled by these extreme values. So that's my first remark here. So if a data set is skewed, leaning toward one side versus the other, And that could be leaning towards the low side or leaning towards the high side. Okay. Then we use resistance statistics. And we already saw that the median is more resistant to these extreme values. And if it's leaning towards one or the other, then we're just like, okay, definitely if it's leaning towards the high side or low side, then the mean is going to be pulled in that direction. And so we're going to use a resistance statistics like the median to find out where's the middle. So as a good measure for center, we go to the median. Mode is another average. So if people use the word average, it could be any of these three, the mean, the median, or the mode, if they're vague about it. And data sets can have more than one. And I am going to put this, we'll stop it too. So if a data set has two values that occur the most often, we call it bimodal. And if it has just one value that occurs the most often, we call it the mode. After that, we really just say it has no mode. Okay. And let's write that down. Data sets can have no mode. That happens. Maybe everything happens just as often as everything else. Having no mode is rare, but easy to see from a bar graph or at first glance at a data. So, no mode. On a histogram. Okay, because remember that a histogram is just a bar graph for numerical measurement data or quantitative data. Okay, or, and I'm going to put this, but easy to see, so no mode is rare, but easy to see on a histogram or at a first glance of the data. And I think that's why it's popular with the car salesman instance, because they're just really doing a quick scan of all the data and they're like, oh, okay, the mode is, I don't know how much a car is right now, but whatever. And the last remark here is really about your calculator. So the Excel commands are average, median, and mode, but all of those measure the center. So mean, median, and mode. They're used to measure the center of a data set. And the Excel commands. So in my videos, I'm using my calculator, and I will show you how to use the calculator to find all of these things as well. But in Excel, I mean, all of these spreadsheets will do this. So will the, Google spreadsheets or Google Sheets and other, spreadsheets. They usually are programmed with these commands. Excel specifically is, let's write this down, our average, And when they say average, they mean the mean because it's the most typical average used. The command median finds the median, and mode. Okay, so I wanted to just tell you that when people use the word average, it really could mean any three of these, the mean, the median, or the mode. But in Excel, it specifically says average. Your calculator doesn't do this. So your calculator actually just uses the symbols. It has a smaller screen, so it uses the symbols to do that. All right. I also mentioned in my notes that if you look at page 155 in your Mercer and Sebecki book, then it explains exactly how to find the averages using Microsoft Excel, which then would be the exact same instructions for using something like Google Sheets. Exam 4, let's take a peek. A class of 10 students scored 75, 87, 92, 68, 100, 68, 84, 82, 54, and 0 on the first exam. Because they practiced, so those are pretty good scores. For a math test, actually, very good scores. But one student didn't show. Boop. Got a nothing. Calculate the mean. Okay? We got this. So we're going to add up the scores and we're going to divide by how many. Let's get to it. Calculate the mean. 75 plus 87 plus 92, 68, 100, 68, 84, 82, 54, and 0. Divided by, okay, it says 10 students. Is that true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it. And I'm going to put that on my handy calculator. But I can clearly see that this is starting to get tedious on the calculator. So we definitely need to, at some point, figure out how to do it more quickly on the calculator. Average, mean average is 71. Got it. What is the meaning of it in the context of the situation? Okay. The class averaged, averaged I don't think we need the word A. 71%. On exam 1. Do you think the 0 should be included in the calculation of the mean average, and why? Well, different students have different opinions on this. And I would say that some students agree with the teacher's opinion on this. I suppose some teachers might have different opinions, but I don't think I've ever found one. But that could be because I run with a crowd who's similar to me, you know, in philosophy. So do I think that the 0 should be, so this is an opinion question, but in my opinion, the 0 should not be counted in the average because this person, I mean, they didn't even perform. They didn't have the opportunity, or they didn't take the opportunity to actually try it. And by the way, I always tell my students, who cares if you even get a 30% and you feel like humiliated by it? A point is a point. And sometimes you'll have bad days and bad weeks, and sometimes you'll have good ones. So show up. Showing up even when you don't think you're going to perform your best is A-okay. Showing up is really important in life. So in my opinion, the 0 should not be calculated in this average because this person, even though they are part of the class, they really didn't take the test. So, I mean, I can't really judge that as a performance on exam 1. So do you think the 0 should be included? No, I don't. And that's because the 0, this person did not perform on the exam. So this average is really talking about how did students do on exam 1. But this person didn't do exam 1. And so I think it's a misrepresentation of the class. So do you think the 0 should be included? No, I don't. Why? It doesn't speak to how well all students performed on exam 1. Okay. So I don't think that if that student had taken the test, they probably would have gotten a 0. I don't know. I mean, it's very challenging, in my opinion, to get a 0 without showing up. But, I mean, if you show up. So let's calculate the median. Okie dokie. Got it. Right on. If we're going to calculate the median, we're going to have to put these numbers in order. Oh boy, they're up here. Okay. So let's order these values. So 0 is definitely the lowest, and then I see a 54, a couple of 68s. So a 0, 54, 2 68s, 75, and then we have some 80s. So 75. We've got an 82, an 84, and an 87. A 92 and a 100. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everyone was included. And then we find the middle. All right, right on, here we go. So, scooching towards the middle. Right in between the 75 and the 82. Okay, so the median splits it into the low scores and the high scores, and that happens right between 75 and 82. So I'm going to actually have to do a side calculation. 75 and 82, right in the middle of that. Okay. I get 78.5 is right in between 75 and 82. Oh, that makes sense. That's 3.5 above 75 and 3.5 below 82. So calculate the median. The median equals 78.5. Ah, I see. So and that even includes the 0. So the middle is right around 78.5. That's much different than the 71% that included this 0, that extreme value. So this was much more resistant to this 0 low score. What is the meaning of this in the context of the situation? Okay. Again, the class averaged a 78.5 on exam 1. Okay, not to be confused with this statement I made over here, the class averaged is 71% on exam 1 versus the class averaged is 78.5 on exam 1. In this one, the average I used was the median. On this one, the average I used was the mean. Yeah, so beware. This word average, it can mean different things. Calculate the mode. Which one happened most frequently? 68. 68 happened twice and every other score happened once. So the mode is a 68. What does this tell you about the situation? Well, that would be interpreted similarly. The class averaged a 68 on exam 1. So we could interpret this as averaged. There we go. Averaged 68%. But I think most people would say, does this 68 really represent the whole data set? That's weird. So I would actually change this to 68 happened. 68 was the most frequently occurring score. And now I think about the histogram and bundling some of these together, because it's true that when I'm in class, face to face, my students demand, well, they always ask, I wouldn't say they're demanding it, but they always ask, like, how many A's did people get? So they're really asking 90 and above. How many B's were there? So they're really asking how many 80s, how many C's, how many D's, etc. So they ask for all kinds of these measurements. After this section, a lot of my students prefer to have more than one measure for center. And they like to see this in a frequency table of A's, B's, and C's. They like to see the median, and they like to see the mean. A scared student scored a 58, a 72, and a 63 on the first 3 exams in this course, Preparatory Mathematics for General Education. You know, the course that goes into Gen Ed Stats and Gen Ed Math. What is the student's mean average right now as it stands? So we would add these and divide by 3. Let's do that. Handy calculator, 58 plus 72 plus 63, enter. Then divide by 3, and I have to round it because it's an infinite decimal. About a 64.3 is their mean exam average at this point. Okay, that actually makes sense to me. There's a high F here, low C, and a low-ish D, so it's a middle D is their average right now. What would the student need to get on the 4th exam in order to average a 70%? Okay, well, that would mean that their average would be computed by taking 58, 72, 63, and some other score. And then that average would actually be out of 4 exams instead of 3. And we would need that to equal a 70%. Well, in order for, so right now, if you're looking at this, you could use guess and check in order to find this 4th score. But I know that this written as an equivalent fraction. Okay, so I'm going to use my fraction knowledge in order to work this out. So as fourths, so 4 times 270 is 280. Okay, so 280 out of 4 is equivalent to 70. So really we're saying this total in this numerator has to total to 280. So I'm actually going to take this 280 and deduct away these initial 3 scores in order to solve this problem. So I'm going to take 280 and subtract 58 I'm going to subtract 72 and I'm going to subtract 63. Doing that on my calculator, I end up with 87. Okay, so what do they need on the fourth exam in order to average 70%? They need an 87% on exam 4 in order to average a 70%. What would this student need to earn on the fourth exam using the median? Oh, very interesting. So here, use the mean, but here using the median. Okay, let's list it out in order. So in order, lowest was a 58, then a 63, and I'm not sure, this is pretty high. So, and if I put the 72 right here, immediately in between, okay, so just a quick check, 63, in between 63 and 72 is a 67.5, which wouldn't make it. Okay, so I know that the next score, right, so here's the deal. If we include, okay, let's see, we have a 72. Even if we, okay, so if we put the 72 here and we include a higher score, who knows? I don't know. Even if they scored a 90, then the student will have a median of 67.5. So if they score high, then it won't really pull up their median. If they scored low, then it will probably pull that median down. If they scored lower than a 72, let's suppose they score a 70 itself, then that median actually went down a little bit. Directly in the middle of 63 and 70, so what would the student need to earn on the fourth exam in order to average a 70% using the median? It can't be done. It can't be done. Can't. Okay, so if we were using the median in this case, there would be no hope for the student to average a 70. So, but I have yet to find a teacher who uses the median when they are judging how a student performs. So leaving out the extremes. Okay, let's talk about how to use the calculator in order to stop doing these all by hand all the time. So using your graphing calculator, find the mean and the median for these temperatures that are measured in Fahrenheit. Okay, so normally, so when I say use your calculator, I don't really mean write it out and then type in the addition or write it out and then compute this on your calculator. What I really mean is, let's do this. All right, so what we're going to do is we're going to go to Stat. You see this? And, oh, I already have a lot of data in here. I'm gonna clear it out quick. So when you go to Stat and then Edit, you should see this. And what we're going to do is we're going to put into list 1, we're going to put in our data values. Now, if you're going to put in a negative, make sure you use this. If you use the minus sign, your calculator will get so confused that it will just say error. So negative So first in my list is negative 2.0. Got it. Then 9.3, negative 0.7, 10.8, a temperature of negative 4. Oopsie, not 4.2, but 4.5, 6.6 degrees Fahrenheit, and negative 1.4. This is a cold month. Okay, so here's our list. So I had gone stat, and then edit, and enter, and then I put in all of these data values. And now what I'm going to do is I'm going to go to stat for statistics, and I'm going to tell it, by the way, these sorts list it. This would be in ascending order and descending order. But I'm going to calculate, so I went over to calculate. By the way, when I say over, I use this, to one variable statistics. We only have one variable, we have temperatures. So up here, I hit enter. I don't have this in a frequency table, so I don't need this. It's blank, and then I hit enter again for it to calculate. Now, immediately, I see the X bar at the top. That means that your calculator is always assuming that something is a sample, which is fine. Instead of putting a mu here, they put an X bar for sample. You'll know the difference. I definitely think that we have a sample actually, so they're right. We have a sample of temperatures. Now, here's what I see. I see the X bar, so that's our mean. And if I arrow down, so I'm going to use this button to go down, I see the median. You will actually find more if you continue to arrow down, but we need the median, which was negative 0.7 degrees, and we need the mean, which is 2.6. Okay, so use your calculator to find the mean and the median. Okay. The sample mean was approximately, because we're rounding it, 2.6 degrees Fahrenheit. I never do more precision than what has been given to me in my data set. And then, so that was our mean average, and our median was negative 0.7 degrees Fahrenheit. Write down the process for using your calculator to find the mean and the median. Okay, so just to jot this down, we went stat, edit, enter, and then after that, put data into a list, preferably list 1, because that was the default when we were doing the statistics on it. Okay, so put the data into the list. Okay, and then, so we did this first, and then second, we hit stat, and then we went over to calculate, hit enter, and from there we made sure that it was the correct list. So as long as it said L1 and we put our data into L1, then we hit enter again. We hit enter again to tell it that it wasn't a frequency chart, and then it appeared on calculate, and we hit enter one more time for it to show us all of the business on all of the statistics for that data list. Okay, so just to show you how instead of doing this all by hand, you can just put it into the data list one time and not even in order, and it will compute for you the mean and the median. It does not compute for you the mode. So that you would have to do by sight. Okay, so as a quick summary of what we did, we were really talking about the center of a data set. So given a data set, what is it centered around? And in order to compute those, the center is the averages, the mean, the median, and the mode for any data set. We compared the use of different scenarios. So what if there's an extreme value? What if it's like skewed to one direction, or should we be inclusive of everything? So they're used differently to talk about different data sets depending on whether there's extremes or not, and depending on whether they want to be lazy or not. I call the mode the lazy average. Write the meaning of the mean, the median, and the mode in the context of a problem. We did that. And we want to be aware that when we see the word average, it could mean any of these three. Most commonly the mean, but definitely could mean any of these. And then use the graphing calculator. In your book, they talk about Excel to find the mean and median of quantitative data. And so we did that at the last minute here so that we could shorten our by hand calculations. Okay, so in the end, we're really talking about if you were going to summarize this data set, on average, about what are the values?